This is the completed unit circle showing all special points, special because they are made by special right triangles, such as this one right here, this little 30, 60, 90, 30, 60, 90, and this 45, 45, 90, and all of the 30, 60, 90s and 45, 45, 90s all the way around. Don't forget, the unit circle has infinitely many spots on it, infinitely many degrees. I could do 15 right here. I could say this is 15 degrees. I could say this is pi over 12. All right, that's half of pi over 6, just like 15 is half of 30. And I could give the cosine and sine coordinates of 15 degrees. Right? They are cosine 15 and sine 15, 0.97 and 0.26. But that's not on my completed unit circle. Why not? It seems like there's a gap there. Why not go every 15? Well, there's no such thing as a special right triangle that's a, 15, 75, 90. All right, there's only 30, 60, 90s and 45, 45, 90s, which means I can't tell you the sine and cosine of 15 degrees without my calculator. I can of 30 and of 45 and of 60. And that way we have some good reference points, 3 in each quadrant, not including the poles. And so this also allows us to do some non-calculator questions. But this would be considered a completed unit circle. Now, shortly, you may not believe it, but you're going to be able to memorize, you're going to be able to fill out all of the info on this chart. Each location has a degree measure, like 30, and a radian version, right, an arc measure, pi over 6. Pi over 6 is the same as 30, it's just in radians and degrees, and a coordinate, a set of 2 coordinates, an x and a y, which are the cosine and the sine. You're going to be able to do that for all of these locations. It seems like a lot to memorize, which is why we're not really going to memorize it. We're going to look for patterns and be able to generate it on the spot without really memorizing, right? We're going to think about, we're going to visualize where is this angle, how far up or down, left or right is it, and so on. Now, to start out today, we're just going to focus in on the first quadrant. Once you get the patterns down in the first quadrant, you should be able to extend those over to the other 3 quadrants, just with some symmetry. So here is a zoomed in version of the first quadrant. So we're going to talk about 5 spots today, right here and here. So we're going to include all straight east and straight north as part of the first quadrant. And we're going to talk about degrees, radians, and cosine and sine of each one of these points. Now, degrees, a standard position of any angle is counterclockwise from east. So this position is 0 degrees, meaning I have not rotated at all from east. These other important spots are 30, 45, and 60. Again, because they are based on the special right triangles. So you can count by 30s, but also in between there you get that 45 spot. And then straight up would be 90 degrees. All right, if I get all the way to up, I have rotated 90 degrees. All right, so those shouldn't be much of a problem. You can pretty much just, deduce those given that you know what a 90-degree angle is and you know what the special right triangles are. We would continue that pattern on and we would get to 120 and 135 and so on, but we'll do that when we get to the other quadrants. All right, so let's talk about the other versions or the other info that's special about these spots. Let's do radians. I'm going to do radians in blue. 0 degrees is 0 radians. Okay, so whether I'm measuring the amount of degrees that I've spun around or how far I've traveled around the outer edge of the circle, if I'm right here at the starting point, I haven't moved at all. So 0 radians. Now, 30 degrees. We talked about how to convert degrees to radians, but you don't want to have to figure out the degrees and then multiply it by pi over 180 every single time. That's how you could. 30 degrees times pi over 180. 30 over 180 is the same as 3 over 18, which is the same as 1/6. So this spot is pi over 6. We're going to do more of a geometrical approach, not a convert every time. I need to be able to find that, to come up with that pi over 6 a little more quickly than that. So think about this. The circumference of the entire unit circle. Circumference is pi times d. Since the radius of this circle, d for diameter, since the radius is 1, the diameter is 2. So the circumference is 2 pi. So all the way around the outside edge of this circle is 2 pi units. All right, if this is a circle with radius 1 mile, then the outside edge is 2 pi miles. So that's a little bit more than 6 miles. The whole thing's 2 pi, which means the top half of the circle is 1 pi. Makes sense, right? Which means the first quarter of the circle is half of pi, which means the first half of the first quadrant, that's an eighth of the whole circle. It's a fourth of 1 pi. And then we kind of stop. We can't really divide it in half anymore, but kind of with the same logic. If we ignore these 45 lines, this one and this one, and go by sixths instead, then these 30-degree angles, 30, 60, 90, 120, 150, 180, that makes 6 sections, and when you divide up the pi, you get pi over 6. So this is 1 pi over 6. And then the next one is 2 pi over 6. All right, but 2 pi over 6 is the same as 1 pi over 3. And a minute ago, I had this one marked. This one is pi over 4. Okay, so those come from keeping in mind the top circle. The top of the circle is pi. These are just fractions of pi. 30 degrees is a sixth of the way to 180, a sixth of the way across the top half of this circle. So therefore, it's pi over 6, since the top half of the circle is pi. All right, so individually, I could take each one of those and multiply them by pi over 180, but better than that, we're going to find patterns and memorize sort of where they all are. Back to the top, 90 degrees is pi over 2. All right, so when you're getting down radians, probably the biggest hiccup is having to realize that a quarter of the circle is a half of pi. All right, the entire circle is 2 pi, half the circle is 1 pi, a quarter of the circle is half of pi, and those, being off by a factor of 2 can make them a little confusing. All right, so I would say degrees is the easiest part, radians, medium, and now in red, let's do the coordinates. What are the XY coordinates, which, remember our connections to right triangle trig, are the sines and cosines of all the angles. All right, so this first one, since this is a unit circle with radius 1, my coordinates are x is 1, y is 0. That's the reason that if you go to your calculator and type cosine of 0 degrees, you get 1. If you type sine of 0 degrees, you get 0. What that's telling you is if you're at 0 degrees at this location right here, your x coordinate is 1, your y coordinate is 0. Makes sense, right? So let's move our way up. 30 degrees or pi over 6. How far to the right is it, and how far up is it? That's our cosine and sine. All right, like I showed you earlier, these are the special spots because I can find these without my calculator because they're special right triangles with radius 1. All of these 60s, as I would call them, or 30s I should say, the pi over 6 spots, ignoring these middle ones for just a minute, they are all going to share the same basic coordinates. They're all going to have 1/2s and square root of 3 over 2s. The long side of these triangles is the square root of 3 over 2. The short side is 1/2. So what you need to think of when you're trying to find the cosine and sine of 30 degrees, slash pi over 6 is, do I move left or right? Do I move right the long distance or the short distance? And since this is 30, I'm at the shallow of the two. All right, 30 and 60 are going to be the ones that are easy to confuse. I'm at 30. I'm going more right than I am up, which means the right, the cosine, the horizontal movement is the longer side of the two. The square root of 3 over 2 is longer than 1/2. 1/2 is the distance that I go up. Now, when I have rotated up to 60 degrees, that's going to reverse. At that point, I'm going over 1/2, the shorter of the two distances, and I'm going up square root of 3 over 2. So that's cosine, x coordinate 1/2, y coordinate square root of 3 over 2. All right, so don't forget these are actual coordinates. If this is x equals 0, and this is x equals 1, this is x equals 1/2. These are literally coordinates, how far left or right, up or down, all of these spots are. Now, you'll notice of all of these pi over 6 or 30 spots, so I'd say that meaning I'm going to ignore the 45s, the ones in the middle of the quadrant, and I'm going to ignore the straight up and down ones. They all share the same basic coordinates. It's just sometimes they reverse, sometimes they're negative. So it's going to be your job to decide at these locations which one comes first, the 1/2 or the square root of 3 over 2, and which ones are positive and negative. We'll get to more of that later. Now let's talk about the top real quick. The coordinates up there shouldn't be a big deal. That's straight up 1 unit, so that's x is 0, y is 1. And then we'll wrap it up with this 45-degree location. Remember your other special right triangle. This is a 45, 45, 90, hypotenuse 1. The easy thing about these 45s, which would be here and here and here and here, right in the middle of each quadrant, the ones that have a 4 on the bottom in radian form, they have the same x and y. They have the same sine and cosine. They are both square root of 2 over 2. All right. When you move to other quadrants, depending on where you are, the x's and y's will go from positive to negative. But every single one of them, x and y are both square root of 2 over 2. Plus plus, minus plus, minus minus, plus minus. That's the only decision you have to make. Okay? So, first quadrant, unit circle, that's it. So the questions you need to be able to answer at this point are, what is the sine of 60? Okay, so when you're trying to think about where's the sine of 60, the first thing you should do is visualize or sketch where is 60. 60, I know it's not the middle of the quadrant, and I know it's the tall one. It's not this short one over here at 30. I've rotated 2/3 of the way up to the top. It's more tall than it is sideways. It's more up than it is right, meaning the cosine is the short side, the sine is the long side. So sine of 60, square root of 3 over 2. Cosine 60, 1/2. Okay? You can see the patterns, you can see the symmetry, and hopefully you'll agree, if you can understand these based on our special right triangles, it won't be long until you can do all of it. All right, so we're going to extend in our next video to the full unit circle, but for now, just the first quadrant. All right, hope that went well. I'm pretty happy about it personally. I love the unit circle. I've got a tattoo of it. Young out.